For lesson 9's homework, we're going to start to talk about the law of sines, which, if we remember, we'll write it here on the top of our page, it was A over sine A equals B over sine B equals C over sine of C. So remember, we can only use two of these at the same time, but it's the side length over the sine of its opposite angle equals the side length over the sine of its opposite angle. And this was the first time we were able to use trig functions when we are not in a right triangle. So if we look here in triangle BUG, so I'm not going to worry about drawing a right triangle or anything specific here. It doesn't have to be drawn to scale. Angle B is 78 degrees. Angle G is 42 degrees. And G, so if they say side G, that's the side opposite angle G. In other words, BU. So there we go. There's our 99. Find the length of side B, which is lowercase b. All right, so therefore opposite the angle B. So we have a nice setup here. We have two sets of opposites. So our first set of opposites is with angle G. We have 99 over the sine of 42 equals B over the sine of 78. So nothing about angle U or side U was useful to us here. So it's a proportion. We're going to cross multiply. But all of these law of sine questions take a couple of steps. So we get B times the sine of 42 equals 99 times the sine of 78. Just like we would in one of our division problems, we're going to divide both sides by the sine of 42. Now, one thing that'll probably be helpful here is if you were to bring up or use your fraction button on your calculator. And if I just put a little screenshot of my calculator in there, you can see how the fraction button is a really nice feature of newer calculators. If you have one of the older calculators, then you're going to have to put it in like I did on the bottom and just be really careful with your parentheses. So that's going to give us that B equals, and to the nearest tenth, we get 144.7. In the second one, triangle XYZ, angle Y is 125. So if you feel so inclined, you could make an obtuse triangle. But again, we're not really assuming things are drawn to scale. So angle Y, X, and then Z. So Y is 125 degrees. Angle X is 18 degrees. And the measure of side Y is 112. Find the length of side Z. Well, what we have to do is we don't have angle Z, so therefore we need that one, and that's pretty simple. We're going to add up the 125 and the 18 to get 143. We'll subtract the 143 from both sides, and we get 37 degrees. So now we have enough information to set up our problem. Okay, remember we're talking about opposites, so the 37 and the side Z and the 125 and the 112. So 112 over sine of 125 equals Z over the sine of 37. Again, we'll cross multiply. Z sine 125 equals 112 sine 37. We'll divide both sides by the sine of 125. And if we take a second and put this in our calculator, I'm not going to bring the screenshot necessarily up on my screen this time. But we end up with, again, this time to the nearest hundredth, we end up with 82.28. In our last one, a baseball fan is sitting directly behind home plate in the last row of the upper deck. The angle of depression to home plate is 30 degrees. And the angle of depression to the pitcher's mound is 24 degrees. The distance between the pitcher's mound and home plate is 60.5 feet. How far to the nearest foot is the fan from home plate? So we're going to end up with a couple of different things here. So they told us that the angle of depression from the fan to home plate is 30 degrees. So this piece out here is 30 degrees. And then the angle of depression from the pitcher's to the pitcher's mound is 24 degrees. So if that whole angle of depression is 30 degrees and the pitcher's mound part is 24, that's going to give us 60 degrees. Excuse me, not 60, 6 degrees for that angle that fits kind of inside that obtuse triangle that we see. So 6 degrees. It tells us the distance from home plate to the pitcher's mound is 60.5 feet. They want to know how far to the nearest foot is the fan from home plate. So we want to find that side right there. Well, it seems kind of like we're out of options here. However, we do know that between our horizontal like sight line up here, we have our transversal, that's parallel to our home plate and pitcher's mound. So that 24-degree angle of depression to the pitcher's mound is also the angle of elevation from the pitcher's mound. So now we have two sets of opposite sides in our triangle. So that's going to give us 60.5 over the sine of 6 equals x over the sine of 24. We'll begin to cross multiply. We get x sine of 6 equals 60.5 sine 24. We'll divide both sides by sine of 6. And we end up with some quick calculator button pushing. We end up with x to the nearest foot, 235.4. So you get 235 feet from home plate to the fan. Now again, we had our big angle of depression is 30, our smaller one is 24, so that's where we got our 6 from. The angle of depression to the pitcher's mound was 24, so angle of elevation is 24 degrees, alternate interiors, and then we were able to do our law of sines to solve for our missing piece from there.